Hello everyone, today we're going to talk about more elaborate factoring, so a little bit higher level math here into the Algebra 2. We're going to be factoring polynomials that are quadratic in form. We're going to be factoring by grouping, including factoring out a GCF, a monomial factor, and making sure we factor as far as we can go. To begin, let's talk about factoring by grouping. We're going to see a couple of examples on this page that look different than problems we've seen before. Not to fear, we're going to talk about it in relevance to our flowchart that we usually reference, which includes the fact that now you're seeing four terms up in these examples. So let's take a look at it. Example 1, we have xy plus bx plus ay plus ba. So here, of course, the first thing we ever do when we reference our factoring flowchart is we check for a GCF. You'll notice there's nothing that is in common amongst all four terms. But you'll notice I'm saying that word four terms. We've never had that before. Anytime we have four terms, we're going to factor by something called grouping. So what we do is this, boys and girls. You take your four terms and you group them into two separate groups. So for me right now, and in Algebra 2 for the most part, we're going to group the first two and the last two. When you get to higher level math, we're going to have more complicated grouping than this, but for now, we're going to start with this. So what I need you to do right now is I need you just to focus on that first underline, xy plus bx. Ignore the ay plus ba. What is the GCF of xy and bx? I'm hopeful that you can all tell me that that's an x. So when I pull an x out of xy plus bx, I'm left with y plus b. That was good. So let's keep it going here. Now let's check out the ay plus ba. So now you're ignoring the xy plus bx. And you're thinking just about ay plus ba. What is the GCF of ay plus ba? Hopefully you're saying a. Now what I want you to do though is I want you to write down a plus a here for me. Because we're going to take out a positive a because the first thing in that group is a plus. When I pull out a positive a, what am I left with? Y plus b. Alright, so that's good. So far so good. We've done two separate GCF problems within this problem. Now is where the Algebra 2 comes in. Now what I want you to notice is, what does this whole thing have in common? It's something you're not used to. What it has in common here is a y plus b. The first part has a y plus b and the second part. So we actually pull that out in front as a binomial GCF. So we're going to put a y plus b in front. We just write it once in front because it's a common factor. And what we're left with are the things in front, our original GCFs. So in this case an x and that plus a. And we're done. So I know that's a little awkward to us. Let's go ahead. We're going to try another example here. Example 2 is a squared plus 2ac minus ab minus 2bc. So once again, referencing our factoring flowchart, is there a GCF of the entire four terms? No. So because I know that there are four terms here, I'm going to factor by grouping. First, we'll group our first two together. The GCF of a squared and 2ac is a. I pull that out and what am I left with? Well, it's going to be an a plus 2c. So far so good. Now we're going to move on to the next two. When I look at the next two, we have to be careful. Remember we talked about this before. When we find the GCF, it's whatever the first term is. What I mean by that is the first term here is a negative. So we need to pull out a negative GCF. I'm going to pull out a negative b. The GCF of negative ab and negative 2bc is a negative b. Remember, you need to be extra careful when you pull a negative GCF out. Negative ab divided by negative b is a positive a. Negative 2bc divided by negative b is positive 2c. And lo and behold, you should see another thing happening that happened before. We now have a common GCF of a plus 2c. So we pull that GCF in front, a plus 2c. And whatever is left over goes in our other parenthesis, a minus b. and those are our final solutions. I want you to go ahead and try this problem out right now. Hit the pause key and return when you're ready to check your answer out. Your answer should be a plus b times r plus 5. If you got it, great. If not, let's talk about it in class together. Alright, so now we're going to talk about factoring polynomials that are quadratic in form. And before we get into that, I just want to remind you of some exponent rules that we've been talking about. So you'll remember in this first example, x squared times x squared. How do we multiply those together? Well, you remember the base stays the same. And when you multiply, you take the exponents and you add them. So 2 plus 2 makes 4. So you'll remember x squared times x squared makes x to the 4th. So x to the 4th times x to the 4th makes x to the 4 plus 4 makes 8. Great. We're going to use that now because we're going to be doing some factoring similar to what we've done before, but on a higher level, an Algebra 2 level. So let's go ahead and get right to it. Example 1 of a polynomial that's quadratic in form. So let's treat this just like we would treat anything in the past. I look at my x to the 4th plus 3x squared plus 2, and the first thing I check for is a GCF, but there's not one. So we go ahead and we see that I have a trinomial. So I'm going to MAF. I'm going to multiply my first term times my last term, x to the 4th times 2, to get 2x to the 4th. My addend is the middle term, 3x squared. So now I need to think of my two numbers that multiply to 2 and add to 3, which are 2 and 1. Here's where we need to be careful in this problem. Pay special attention to the exponent here. I've got a 4 here and a 2 here. That's different than anything we've ever had before. You'll remember you want to put the unit from the middle term on your addend as well as your factors. So this is 2x squared and 1x squared. And that's it, guys. Everything else works the same. We're going to go ahead and we're going to put our first term in the middle. So x to the 4th in the middle, our last term in the bottom right, and of course we don't put our ma in the box, but the factors will go on the diagonals. 2x squared and 1x squared, and it's GCF time. The GCF of our first column is x squared, our second column is 2, first row is x squared, and second row is just a 1. So our answer turns out to be these terms we have on the side, which means the final solution is x squared plus 2 times x squared plus 1. Now we should always check to make sure we can't factor any further. X squared plus 2 and x squared plus 1 cannot go any further. They're binomials, but they are not difference of squares. Alright, in example 2, let's get to it. First thing I check for is a GCF. There is a GCF of 2c. So I pull a 2c out and I'm left with c to the 4th. Because remember, c to the 1st times c to the 4th will make that c to the 5th I'm looking for. Negative 50 divided by 2 makes negative 25. So now what am I left with? In the parentheses I have a binomial. Right now we're going to check, could that binomial be a difference of squares? Well, it certainly is a difference. Can I take the square root of both of those? I can. Well, we haven't done this before, and now's the time to begin. The square root of c to the 4th is c squared. The square root of 25 is 5. So you'll remember with the difference of squares, I'll put a c squared plus 5, and I'll put a c squared minus 5. But remember that GCF of 2c is in front. I should always check if I can factor further. Well, I certainly can't factor c squared plus 5 further because it's not a difference of squares. And neither is c squared minus 5. Why? 5 isn't a perfect square, so we're all done in this problem. Final solution is this circled answer. So now we need to make sure we factor completely. So let's take a look at some examples that might pop out at first that you may or may not know how to do. So we're going to try this example. Example 1, x cubed minus 2x squared minus 9x plus 18. Is there a GCF of the whole thing? No. Is it a binomial, trinomial, or 4 plus terms? It's 4 plus terms, which means now we're going to group. So we're going to group our first two and pull out a GCF of x squared. When I divide x squared out of those, I'm left with x minus 2. Now we take a look at our second set of terms, negative 9x plus 18. Remember, because the first term here is negative, I pull out a negative GCF. The GCF of 9x and 18 is going to be my negative 9. Be very, very careful pulling out that negative GCF. Negative 9x divided by negative 9 is x. 18 divided by negative 9 is negative 2. Once again, we'll notice that we have a GCF here now of x minus 2. We put that x minus 2 in front once, and our leftovers, the x squared and the minus 9, go in our second parenthesis. And we'd be pretty happy if we got this far, but we're not done yet, because x squared minus 9 can be factored with the difference of squares. Remember, that turns out to be x plus 3 and x minus 3. But make sure to bring that x minus 2 down with it. So your final answer is x minus 2, x plus 3, x minus 3. You have to factor and factor until you can't factor any further. Alright, here's a try for you. Try to factor this problem completely. X squared y minus 3x squared minus 4y plus 12. Hit the pause key and come back to check your solution. The solution is x minus 3, x plus 2, x minus 2. Remembering those parentheses can be in any order. If you didn't get the problem, let's chat about it tomorrow. To wrap up, remember to always, 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 always check for a GCF first. Now that we might have 4 terms, we have a new strategy for going ahead and factoring. That's called grouping. Make sure, if we have a quadratic informed problem, that you label the F of your factors in MAF for your boxes according to the original problem. If the degree of our polynomial when we factor is greater than 1, always look to factor further.